So this is the fourth of the halogen videos, and this is definitely the last one. I had to break off from the last one because I actually had to go and finish making my dinner. So we looked at the displacement reactions of the halogens, and these were the three reactions that we said were successful, where chlorine can displace the bromine from potassium bromide. So if we had chlorine water and we reacted it with aqueous potassium bromide, we would form bromine and potassium chloride. We'd balance that. We also said that chlorine was able to displace iodine from potassium iodide. So here's the iodine being formed and potassium chloride again. And the other reaction we said that would work was that bromine was reactive enough to displace the iodide, or displacing iodide to form iodine. So here's the iodine forming, and KBr made two of those, and it does worry me because I've forgotten some state symbols here, which is very shoddy work. Everything being done in aqueous solution. And a quick refresher in terms of colour changes, so chlorine water and potassium bromide would both be colourless, and it would form colourless potassium chloride solution and orange bromine water, so the overall colour change would be colourless to orange. These two again are colourless, and iodine in water is actually brown, so it would be colourless to brown in solution. And here we would have an orange mixture because bromine water is orange, and iodine, which it's forming dissolved in water, is brown, so it would be orange to brown. Now I'm just going to show you how these reactions work in a little bit more detail, and to do this we need to write an ionic equation. So here's the balanced equation for the first reaction. So chlorine displacing the bromine because the chlorine is more reactive. And to write an ionic equation for this, we split up substances that are ionic and are dissolved. We can do that because when you put an ionic solid in water and it dissolves, the ionic lattice breaks up, so the ions float round independently of each other. So it's actually okay chemically to say, well, actually in this reaction the potassium ion and the bromide ion in potassium bromide are actually separate. We would keep chlorine together because it's not an ionic substance, but the potassium bromide is ionic. Now I'm ignoring that big T at the front for the time being. We're going to work on balancing in a second. So on the right hand side we see, well, is bromine ionic? No, it's not. It's a covalent molecule, so that will stay as Br2. Is potassium chloride ionic? Yes. Is it dissolved in water? Yes. You can tell that because it's aqueous, so you can write the ions for that separately. Hopefully you should know that the group 7 elements all form 1 minus ions, and potassium, which is in group 1, always forms a plus 1 ion. So this is the start of writing an ionic equation, which is far more informative for us than this equation up here. And what you can see is that the potassium is unchanged in this reaction. It's exactly the same on the left as it is on the right. So we'd call the potassium a spectator ion. It doesn't do anything in the reaction, it just sits there. Okay, it's unchanged. So there's no need to really include it. It's superfluous in our equation. So if we were to write this out again without the spectator ions, it looks a little bit easier. So we've got Cl2 aqueous plus Br minus aqueous goes to Br2 aqueous and Cl minus aqueous. And now we need to balance, because even though we have the same charge on the left and on the right, we don't have the right number of atoms. We've got one bromine over here and two bromines over here. So what we need to do is put a big 2 there and put a big 2 there. So this equation just makes it a little bit more, it's just a bit more informative. What it's saying is that the chlorine reacts with the bromide to produce bromine and chloride. Now, exactly what's going on here in terms of the electrons? Well, let me just see if I can move this up a little bit. Here we go. Here's a chlorine molecule. Okay. Here's 2 bromide ions. So here's the bromides. Obviously they're not really drawn to scale, otherwise the bromides would be bigger than each of the chlorine. And hopefully you've spotted that I've left off the minus charge on the bromide. And what happens to these bromides is that they form a bromine molecule. And really I should have drawn these with dots. That's very unhelpful. So, let's have a look at the total number of electrons over here. The 2 bromides, each of them have 8 electrons, which makes 16 electrons over here. But the bromine molecule, overall, if you count them up, actually only has 14 electrons. So the bromides have lost electrons to form bromine. I'm using my words here quite carefully. The bromide, the ion, has lost electrons to form bromine. Each bromide has lost 1 electron, and then these 2 electrons, if you imagine, they suddenly disappear. Let's see if I can use the rubber on here. I'm not quite sure where it is. Nope, I can't find a rubber, so I can't make the electrons disappear. But each one of these has lost 1 electron, and then they bond together covalently, and we go from having 16 electrons to 14 electrons. So the bromides have lost electrons. Br minus loses electron, and we say that a reaction where electrons are lost is an oxidation. Okay. Now where have those electrons gone? Well, those electrons, each one has gone to a chlorine. So the chlorine forms chloride. So here's one chlorine, here's the other chlorine. There's 1 electron from the bromine, thank you very much. There's the other electron from the other bromide. So you form 2 chlorides. So bromide loses an electron, chlorine gains electron. Now if the reaction to where an electron is lost is called oxidation, the reaction where an electron is gained is reduction. And again, we can remember this using the phrase I used in the first video. Lose electron oxidation, gain electron reduction. And because oxidation and reduction are occurring at the same time, we call this reaction a redox reaction. This, I think, is probably one of the trickier bits of the IGCSE chemistry specification. I don't think I've actually, thinking about how I've explained it, I'm not sure I've actually explained it that well. But hopefully it's helped you out with your revision, and this is the final video of the halogen series.